Derivatives. The definition of a derivative comes in different forms. Verbally, a derivative is an instantaneous rate of change at a specific point of a function. On a graph, the derivative at a point is the slope of a line tangent to the graph at that point. Functionally, it is the limit of a difference quotient. The limit on the left is the derivative of a function at a specific point. You can find the derivative at that point by substituting a value for a and a function for f of x. Take x squared, for example. To find the derivative of x at x equals 5, we must substitute x squared for f of x and 5 for a. Since f of 5 is 25, we substitute that for f of a. Finally, we take the limit, but because the limit would result in an indeterminate form, we must divide x squared minus 25 by x minus 5. The result is x plus 5. Now taking the limit gives us the derivative as 5 plus 5, or 10. To find the derivative function, we use the limit on the right. Again, substituting x squared for f of x, we can find the derivative function. After expansion and combining like terms, we see that each term on the top has an x in it and can cancel with the h on the bottom. Therefore, the derivative function is 2x. Notice how the coefficient of x is the previous power, and we took 1 away from the power. As stated in the previous slide, when we took the derivative of x squared, we multiplied x by the power, in this case 2, and reduced the power by 1. We suspect that this will always be the case, but we aren't sure. Let's find out using x to the 4th. By substitution, we get x plus h to the 4th minus x to the 4th over h. Using the binomial theorem, we expand x plus h to the 4th to get x to the 4th plus 4x to the 3rd h plus 6x squared h squared plus 4xh cubed plus h to the 4th, all minus x to the 4th on top, h on the bottom. This negative x to the 4th cancels with the positive x to the 4th, And notice that every other term on top has an h in it. So we can cancel all of those with the h on the bottom. The result is 4x cubed plus 6x squared h plus 4xh squared plus h cubed. Taking the limit results in the last three terms all being 0, so we can get rid of them. All that's left is 4x cubed. So this seems to be true. When finding the derivative of x to any power n, you multiply x by n and then reduce n by 1. So the derivative is nx to the n minus 1. There are some other things to consider when using the power rule. For instance, take this function. If we have a number multiplied by x to a power, we find the derivative by leaving the number there and multiplying it by the derivative using the power rule. So 5x cubed becomes 5 times 3x squared, or 15x squared. Also, when we have a sum of functions, we take the derivatives of each function and add them all together. So the next term is 3 times the derivative of x squared, which is 2x. So the term is 6x. We can write x as x to the first power and still use the power rule. But this time, when we take 1 away from the power, it becomes 0. That's okay because x to the 0 is 1. So we have negative 8 times 1 times 1, or just negative 8. Finally, we treat the constant as a coefficient of x to the 0. Then when we use the power rule, the 0 comes down and makes the whole term 0, so we don't need to write it. The power rule also works on powers in the denominator of a fraction. You just have to bring the term out of the denominator. To do that, you have to make the power negative, then apply the power rule. It also works when there's a number other than 1 on top. You just rewrite it as 8x to the negative 3. Then apply the power rule to get g prime of x equal to negative 24x to the negative 4. To find the derivative of a composition of functions, you can use a u substitution. This means you say that the inside function is u, and the outside function is y in terms of u. Then you find the derivative of u, or of y, with respect to u, and the derivative of u with respect to x. And then multiply them together. Because you can treat these symbols like fractions, and cancel, the result is the derivative of y with respect to x. Once you do that, then you can resubstitute the function back in for u. The chain rule is called that because we can always add links to the chain. First, we must determine the order in which the functions are evaluated. We do the 4x to the 5th first, so it will be u. Then we take the sign, so it will be v. Then we raise to the 3rd power, so it will be y. Then doing the derivative of u with respect to x. And the derivative of v with respect to u. And the derivative of y with respect to v. And multiplying them together, you get the derivative of y with respect to x. Resubstituting gets us the function in terms of x.